Hello and welcome to day 11 of 100 Days of Code in IoT Challenge. I'm Thomas and today I'm gonna make an attempt of refactoring the code that I've written so far on the time control relay module based on ESP8266 controller, and I'm going to try to make the code more event driven. So today there's not gonna be any tinkering with the board. It's just a coding day. Essentially me doing an improvisation on the code refactoring. So let's see if I can make it more cleaner. Yeah. So I'm just going to move to the code now. Okay, let me just start from quick reminder. So I'm gonna go through the code again, starting from the setup function. So yeah, here, connecting to the serial port, then setting the pins, connecting to Wi-Fi, synchronizing the clock on the ESP with the time server. This is required for SSL certificate verification. And then in the loop function, we got those conditionals to check, like if the relay is off, button is pressed, we want to switch on the relay. This is waiting until, like when the relay is on, it is waiting for the time to be switched off. And when it switches off, then also the buzzer is switched on and HTTPRequest to AWS API gateway is being sent. And this one is just to switch off the buzzer. I think this is configured for 2 seconds now. Okay. So the goal today is first to make these two operations here, I mean mainly connect to Wi-Fi really, to make it non-blocking. At the moment it is blocking. If I just click through, you can see we've got delay, right? So while it's connecting, there is a delay for 1 second between every attempt. So, because of that, we cannot really press the button on the device because that needs to be connected. The Wi-Fi needs to be connected first and the clock synchronized and so on. So my goal is to make this non-blocking. So make it possible to actually to press the button, right away, even if Wi-Fi is not connected. As you know, as essentially, I just, for the testing purposes, I've got the relay time set to 3 seconds, I think. It's 3 or 5 seconds. But ultimately, this is going to be more time, right? It's like with the coffee maker, it's 10 minutes, right? So 10 minutes is enough time for the Wi-Fi to connect and everything. Okay. So yeah, so that's the goal, right? Making all of this stuff asynchronous, right? So we can press the button and then in the meantime, the Wi-Fi connects. If it connects, right, then we want to send the request. If it doesn't connect, we don't want to send the request. We just want the buzzer, right? So the buzzer is like a fallback mechanism. The buzzer is always going to work. But Wi-Fi, sending HTTP request might work, might not work. But we don't want this. We don't want the functionality of sending the request to be blocking, to block other functionalities. And that's why I'm going to make it more event-based. But, by event-based, I first mean try to make use of the callbacks. And then we can slowly move into the event-based approach, maybe with the EventDispatcher, aka observer pattern, aka events emitter in Node.js. Okay. So again, yeah. So I'm going to focus on connect to Wi-Fi first. And on this statement, on this while statement, that is blocking. It happens, the Wi-Fi run comparison with WL connected happens in the loop. So my idea is to, in some way, move it to this loop, right? So instead of relying on while, we could rely on this loop function to be executed continuously. However, I'm going to do it through the class. So this, connectToWiFi is gonna become a class. I'm gonna call it WiFiManager. And the first method that I'm going to define is going to be a loop method. So that's gonna be method. Let me just create an instance of it straight away, so we can use it in the loop function, right? So the beginning of the loop function, I'm just going to call loop. So that's gonna sort of decouple the functionality of the Wi-Fi right from the loop function, I guess. Okay, so this is gonna be the place where the actual, the connection happens, right? Those attempts that we have here, they happen because, whenever the run is called on Wi-Fi multi, there is an attempt to connect to the strongest Wi-Fi network. We have only one network configured, but yeah, essentially it tries to connect to this Wi-Fi. Okay, so we need this to be checked in the loop, like that, right? Instead of while, we're just going to have a single check. And instead of checking if it's not connected, we actually want to check if it is connected, right? So when it is connected, we would like to do something. However, it cannot stay in this form. I'll tell you why. Because once the Wi-Fi is connected, we don't want to keep running Wi-Fi multi-run method, right? So we need to have some sort of control variable, maybe class variable, to check if Wi-Fi is connected. So I'm going to call it bool connected maybe, and at the beginning is going to be false. So when this is connected, I'm going to just say connected true, right? And then what we could do is to not run it. So if I could actually do that. So if it is not connected, right, and Wi-Fi multi-run is connected, we want to set it to true, right? So that's going to be the safety mechanism. So once we are connected, this is never going to be executed. This bit is never going to be executed if this is true, right? Because if this condition fails, right, this condition is never going to be, this statement is never going to be executed. Okay, so that's our safety mechanism here. However, we still need to have a way to, initiate connection or disconnection, because at this point, the initial state of connected is false, right? The initial value is false. So if you run it in the loop function, this is just gonna try to connect straight away. But that's not something we want to do. We want to have a connect method here. And this is the method that initiates the connection, right? So what I'm gonna have to do to make it happen, right, to not run Wi-Fi multi-run straight away, is to introduce another flag, and I'm going to call it should connect, right? Should connect false. And only if we want to connect, only if the connect method is called, we want to set it to true. And also we want to have this in the if statement. So if I should connect and I'm not connected, then I do Wi-Fi multi-run, then I do this, right? So that happens first. It checks if it's supposed to connect. If it's supposed to connect and it's not connected already, then the Wi-Fi multi-run happens and checks if it's connected, right? But it's just gonna keep retrying. And only if it happens, we want to set the connected to true, but also we should connect to false, because we don't want to continue to connect, right? Once we connected, we're not going to try again and again, right? Okay. So that's fine. I'm gonna add disconnect as well. So disconnect, what should disconnect do is to change this to false, right? Because it might be connecting at that point. We don't want to keep connecting anymore. And we actually want to do Wi-Fi disconnect. So we actually want to disconnect. And also, right after that, we want to say we are not connected anymore, because we don't really have any mechanism to, at the moment, to constantly check for that. Okay, so that makes the Wi-Fi manager and moves it to the loop, right? So now what I could do here is to just type in WiFiManager connect, right? And that's going to be handled in the loop. However, now I don't have any way to check. I mean, there is internal way on the Wi-Fi static class to check what the status is, but with WiFiManager, there is not really a way to tell whether the Wi-Fi is connected or not. So, and still, I would like to set the clock, for example. I would like to set the clock and I would like to disconnect straight away. So what I could do is to modify my code to be more callback oriented. And the way I could do that is to introduce a method here on connected, right? So on connected, something happens, and that could take a callback. So a function that is void and doesn't take anything, right? fn. And that function needs to be set as a class variable. So I'm going to move this here. Let's call it onConnected callback. Okay, that's null. Initially is null. And then we're gonna do something like that. So when it's connected, whenever it's connected, I mean, it's not like when it's connected, it's just gonna continue on and on. No. OnConnected means that we had the state transition. So from not connected to connected only at this point. Once it stays connected, this is not gonna continue being called, right? And this if statement, what happens inside, makes sure this actually happens, right? Because once it is connected, we said they should connect to false and connect it to true. So this is not gonna be, whatever is inside the if statement is not going to happen again until we change those flags with connect, for example. Okay, so here I have to do another check. I need to make sure the onConnected callback is not a null pointer, because, you know, we don't have a guarantee that someone sets the callback. Okay, so it's not a null pointer. I'm just going to call it, right, a callback approach. So what I could do now is I need to do it before. I mean, if I did it right after, it still should be fine, but to be 100% sure, I'm gonna do it before the connect method is called. So here, onConnected, and I'm gonna pass the C++ lambda function, which is essentially a callback function. That's how you define it. So you got this square bracket, you have this square brackets and then the normal brackets, right? Okay, and here we're going to move this functionality, those lines inside the onConnected, right? So once this is connected, we're setting the clock, we disconnect the Wi-Fi, and now I can actually do it with the WiFiManager. So this is disconnected. Okay, question is this a desired state of the code? No, it is not. Let me explain why. So onConnected here happens every time we have the transition, right? Every time when the transition happens from not connected to connected. And as long as this is fine for the setup method, for the setup function, when we connect for the first time and we want to set the clock and then disconnect, this is not gonna be desired condition for sending HTTP request, because in HTTP request we also want to connect to Wi-Fi, but we don't want to, after setting the clock, we don't want to disconnect straight away. So having this code in here is going to stop sending a request from happening, because, you know, while this will, like, you know, connect to the server, the Wi-Fi disconnects and cannot complete the request, right? So I'm gonna need to modify a code slightly, because the situation we've got here is that we don't want to set a function that listens on connected and is executed every time we get the transition of the state. We want something that happens only once and then it doesn't happen again, right? So instead of on connected, what we need is once connected, right? I'm pretty sure, like, for those who are familiar with JavaScript, with Node.js, this code starts to be a little bit familiar, right? With the events emitter, for example, right? We've got one and once, I think, there. So I'm just gonna introduce another one because on connected is still gonna be useful. You know what? I'm just gonna copy paste it. And here we're gonna have once connected. And this is gonna be once as well. And this is also gonna be, I'm just gonna copy paste and do once connected. Once connected, once connected, this can stay like this, okay. And also I need to check again, so I can copy this and paste. So I got once connected. So I got once connected. And if it's not null pointer, we want to call it. But the difference to the previous if statement is we want to, after that, we want to set it to a null pointer, right? So it happens once, that's it. Right, and now going back to setup function, I'm changing this to once connected. So once connected, this happens once, and that's it, right? Okay, so, you know, before I move to the sendHttpRequest, let me just quickly compile the code and let's do a quick test to make sure this is working. The device is still working as I want it to work. Okay, this is fine. So I'm gonna deploy it now. Okay, it is deployed. I'm just going to connect to the serial monitor now. And yeah, let me just reset it so we see it from the beginning. Okay, yeah, waiting for NTP timesync. So we got this working. There was no serial. You know what? I can actually add the serial print to this. I'm gonna call it once connected so we can see later on. You know, the time is still syncing. So I'm gonna deploy again and I'll show you the messages as well. Okay, deployed, connecting to serial monitor. I'm gonna press the reset button. Okay, so you see once connected, that happened. And now we're waiting for NTP timesync. Yeah, once this is synced, I'm still gonna test the functionality. That's gonna be, you know, the part on sendHttpRequest still uses the old function to connect to Wi-Fi. But, you know, just to make sure the code works. And right after that, we switch to the new implementation. Okay, that's synchronized. Pressing the button now. Switching on the relay. Okay, so that worked. And now I'm just going to quickly change the connect to Wi-Fi on sendHttpRequest to the new one. So what I could do with that, this is gonna be quite nice, I think. So instead of that, I can just do WiFiManager. Once connected, just want this to be run once. This time I need to pass I need to do equal sign in here. That is for the pointer to this. This is the pointer to this object. We need to copy it over to the callback. That needs to be copied because it needs to have access to it. Otherwise we would have the error. Couldn't really run this code. Okay, so yeah, setting the clock, doing all of this stuff. Also, this Wi-Fi disconnect is gonna become WiFiManager disconnect instead. And also we need to do WiFiManager connect, right? Because we're disconnecting it, and then we're disconnecting it here. So we need to reconnect here, right? So here, what's gonna happen is we're setting this to happen once this is connected, once the transition happens, right? And we connect. Okay, anything else to be done in here? I don't think so. That should work straight away. Yeah, okay. Let's run this. So I'm gonna deploy again. Okay, deployed. Okay, that was quick this time. Connected and time synchronized. Okay, so yeah, I'm gonna press the button now. It's working on the new code, switching on the relay. Buzzer. You see, actually it went off before the HTTP request happened. So we don't have the issue with the increased time of buzzing buzzer because essentially I've made everything non-blocking, right? Cool, so that works. That was successful. This is non-blocking. Set clock is still blocking, isn't it? So what I could do with set clock is sort of the same situation, sort of the same approach. I could make a class and then, have those flags, Boolean flags, and the loop method to be run here. I can do that, but I think there is a way to avoid all of this duplication because there would be some logical duplication on it, right? And this is the moment when we can make use of the observer pattern. Let me just quickly remove connectToWiFi and make sure there is nothing else using it. Okay, there is nothing. Okay, so yeah, observer pattern, aka EventDispatcher, aka EventEmitter. Right, just quick explanation how this works. I've come up with a good analogy, which is the YouTube channel. So everything starts from the subscribe, right? So I'm using EventDispatcher as an example here. So as you can see, we got the YouTube channel, we got the subscribers. The YouTube channel is the EventDispatcher instance. And subscribers are just a callback functions that they're gonna be called eventually. And they subscribe to a certain specific event. In this case, this is called video posted event, right? It's like on YouTube, right? You subscribe to the channel, so you get the information, you get notification when the video is posted. And this is what happens here, right? So we got subscribers, callback functions, subscribe to video posted event. And then when this video posted event happens, it is dispatched by dispatcher. Then all the subscribers subscribed to this particular event are gonna be notified. The way they're gonna be notified is essentially they're gonna be called in my implementation, right? Because the full observer pattern implementation, if you look at the design pattern websites, I think is more object-oriented approach than what I'm going to introduce. So they are not, they usually utilize of a notify method. But what I'm gonna do is, it's very similar approach to EventDispatcher or event emitter in Node.js. So we got on and dispatch. Dispatch is when we dispatch the event. We can also pass some sort of information. I'm not gonna do it for now. And then on is when you subscribe to a specific event. Okay, so now I'm gonna go back to the code and I'm going to introduce EventDispatcher to this code, and I'm going to modify WiFiManager to use EventDispatcher, right? So we have a separate logic to handle the events. And we can take any class, any piece of functionality in our code that needs to trigger an event and that might have a blocking operations that we want to make non-blocking operations. So, instead of implementing everywhere these methods for on connected, once connected, what about disconnected, right? I will have to implement on disconnected once disconnected. I don't want to do that in every single class. So instead of that, I'm going to have a central class called EventDispatcher to do this sort of behavior, this sort of behavior essentially for me, right? I can use it as a dependency in other classes. I'm gonna have to do, but I will have specifically this logic somewhere else in the class that is strictly responsible for handling the events, right? So I can remove the responsibility of handling the events from WiFiManager and move it to EventDispatcher. So let me show you how to do it. So first of all, what we need is the actual class, right? So I'm gonna build a class. For now, it's just gonna be the simplest implementation that you can think of. So nothing really sophisticated, no generics and this kind of stuff. Two methods, as I showed you here. Two methods, right? One method is called on. Takes a function. Oh, sorry, not just a function. We need the name as well. So name, maybe I'm just gonna call it event name. And the function that returns void and takes void. A callback function, right? So that would be one method. Another method is going to be once. Yeah, actually I forgot about once, so there are gonna be three methods, sorry. Once is gonna be very similar. And we need a dispatch. Dispatch at the moment is just going to take event name. So, to tell that this particular event is dispatched. Right. Okay, now we need a container structure to contain all of those listeners, right? Because you set them beforehand, and then when the event is dispatched, all of those are being called. And in case of once, they are deleted right after that. So I'm gonna use the vector for this. Vector of pairs. For those not familiar with vectors in C++, they are very similar to arrays, but they have some extra functionality for the memory allocation to be as efficient as possible. And I'm gonna have a pair on it. So pair is essentially a struct that contains of two types, right? So what we're gonna have is event name and a function. So event name is const char pointer, and the function is the function type, right? The callback type. So that makes our pair, and that makes our vector, and I'm gonna call it listeners. So these are listeners. Cool. So whenever on is called, we want to add listeners. We want to do pushback, make pair, and that's gonna be event name and function. The same happens for once. However, I just realized we need to have some sort of way to distinguish between the once and on. So probably on the pair, I am going to put some other type of structure. Yeah, that's not gonna be pair. Cannot be pair, sorry. I need to define a struct, and let's call it listener. I could create a pair on this pair, but that would be a little bit confusing with all of those brackets here for generics. Now, I think it's better if I just do event name const chart. That's gonna be just quickly a struct, then std function. Yeah, that was a mistake in here actually, because that's how it should look like. Void, that's gonna be our callback. And then we're gonna have boolean to check if is once. Okay, so instead of pair, what we're gonna have is the listener here. That's gonna be easier. Okay, so that's what we've got here. Okay, so instead of make pair, that's gonna change a little bit. We will have a listener here, and this is gonna be listener as well. So listener struct, the difference here is this is gonna be false and this is gonna be true. Okay, so now we have a way to distinguish between once and on. So the whole thing actually happens in the dispatch method. What I'm gonna have to do first is to iterate over listeners, and then I'm gonna check if this listeners, this is different than end, and then iterator plus plus. Okay, and if on iterator, if event name, we need to do comparison. So comparison of C string. So we're comparing event name with this event name that's been passed to the dispatch method. And if they are equal, I want to, first of all, I would like to call the callback, and then another check for is once. Because if it's once, right after we call it, we would like to erase it from the vector. So we're erasing it. That requires iterator. So that's what happens, right? This is for once. This is to handle the once. And this is to handle like both, right? Cool. So that makes EventDispatcher working. There could be more functionality here, like, canceling some, unsubscribing. That's gonna be required at some point, unsubscribing from the events. But for now, this is fine. This is enough. Okay, let me just quickly compile the code to check if this is gonna work. I mean, if it compiles. Right, yeah. Okay, it does compile. And now what I'm gonna do is to modify WiFiManager to use EventDispatcher instead. However, what I'm gonna define first is a few const expressions. So we're gonna have const expression here, and that's gonna be const char, and we're gonna call it Wi-Fi connected event. So Wi-Fi connected. And then we're going to have another one for disconnected, right? Wi-Fi disconnected. And that's gonna be Wi-Fi disconnected event. So this disconnected event. Right, so now we're gonna have a nice way to access those, because yeah, what I can just do is to do WiFiManager, and I will have access to those, right? From everywhere. Okay. So that's gonna be the first step. The second step, I basically need a constructor, because I'm gonna have to use the EventDispatcher as a dependency. So WiFiManager, and that is gonna take EventDispatcher, but just pointer to it. So yeah. Gonna define it here as a private class variable, and then dispatcher equals dispatcher. Cool. Okay, so got dispatcher, and now instead of those functions, instead of those methods, I can make use of an EventDispatcher instead. So I'm not gonna need those anymore, but one second. So here, those two cases, when we connect Wi-Fi, this is gonna be where I simply call EventDispatcher dispatch, and WiFiManager Wi-Fi connected event, right? So I'm not gonna need all of this. It's not needed anymore. All of this is not needed anymore. For the disconnected, I can do the same thing. So I say dispatcher, EventDispatcher. Is it called dispatcher or EventDispatcher? Oh, I called it dispatcher. So that should be dispatcher. Yeah, so dispatcher, dispatch, and that's gonna be WiFiManager, Wi-Fi, yeah, another mistake here. Wi-Fi disconnected event. That's what happens here. Great. So dispatcher, dispatch, okay. So this functionality is not required here anymore. Just the dispatcher. This is gonna handle everything. Right, to make the code work, I still need to pass the event. I need to create an instance of dispatch EventDispatcher. I'll just call it dispatcher, that's fine, I can stick to this name. And that needs an address to dispatcher, right? It takes the pointer. Okay. Cool. So now quickly to the setup function. Hopefully this is gonna work. Right. Now to the setup function. So instead of doing it on WiFiManager, the connect is gonna stay here. But now EventDispatcher is the central point. Actually, dispatcher is the central point to add listeners. So here we're gonna have Wi-Fi manager. Once Wi-Fi connected event, and this is where I'm going to pass the callback. And the same thing needs to happen in here. So dispatcher instead of WiFiManager, that's gonna stay here. Great. Let me just compile, see if the code compiles. Right, okay, some issues here. Let me fix it quickly. So, character constant too long for its type. Okay, I see that's just a mistake of the using single quote instead of double quote. And I need to make it static as well. That should work. Let's see. Yeah, now it's working. Cool. Right, okay, I'm going to test it now. There's nothing else that I'm gonna have to add to this because dispatch happens here. Great, okay, so I'm gonna run this. Let's see if it works. Then we're gonna go, if it works, right? If it doesn't, I'm gonna fix any bugs that appear. But hopefully this is gonna just work straight away. Okay, deployed, serial monitor. Right, waiting for NTP time sync. And let's see if it works. Come on, time server. Okay. Right, so we got an exception that happened exactly after the time has been synchronized. Right, so yeah, let me just quickly check. Set clock and disconnect. So it's probably somewhere, something that happens just after once. Yeah, that's definitely EventDispatcher. My guess, okay, yeah. So one thing, I need to change this ++ to this. So that could be one mistake. And another one is, if I erase that, I think there's gonna be something wrong with the iterator. Yeah, it won't have iterator anymore to continue. So I'm gonna need to do the trick with decrementation, I think. That should do. That should do. It's not that I knew about this. To be honest, I've just spent 30 minutes fixing this issue. So this -- trick I just found on the internet. I'm not that good with C++. Right. But yeah, essentially what it says is, notice that the iterator is decremented after it is passed to erase, but before erase is executed. Right? So it happens just before erase is executed. It's decremented by also passed. So some, it's not really magic, but yeah, essentially you need to avoid removing the iterator, because the way the for loop works with iterators, as you can see, we have the incrementation on the iterator after every iteration. And if we erase the iterator, there is nothing to increment on. That's how I see that. If this is not right, let me know in the comments. I mean, the way I just explained it, but that's how I see it. Anyway, that should fix the issue. So I'm going to deploy again. And we're gonna do a quick test. Synchronize, no issue. Nice. So what I'm gonna do is to press the button. Switching on the relay. Switching on the buzzer off. It tries to connect to Wi-Fi in the meantime, and we've got the message from Lambda. Nice. Okay, that worked. Cool. Right, so yeah, let me just make use of the disconnected event as well. So I was thinking I could use the built-in LED. So the LED built-in, gonna send it to output. And let's say at the beginning, here, digital write LED built-in, and I want to set it to low, so it's gonna be on. Counterintuitively. So digital write low. So what I would like to do is when it's not connected to Wi-Fi, I would like the diode to be on. And if it's connected to Wi-Fi, I would like this to be off, right? So at the beginning it's not. So I set it to low, that switches it on. And then for that, I actually need a dispatcher on. Not return. So it's going to switch it off, but only if it is connected. So if it's connected, it's gonna switch it on. If it's disconnected though, so that's gonna be Wi-Fi disconnected event, then it's going to switch it on when it's disconnected and switch it off when it's connected. Cool. And also what I could do here is to remove this duplication on the set clock, right? We have a duplication on set clock because we want the clock to synchronize whenever the Wi-Fi is connected. Not just once. So this is not really the case anymore. This is only the case for the beginning. And because that has been set up before, this one, we don't need this semicolon here. Because this one has been added as a subscriber first, this subscriber is going to be notified first. So we're gonna get the clock set before the Wi-Fi is disconnected. I think this is how it's gonna work. Okay, so the last deployment today, right, that's deployed. Connecting to the serial monitor, connected to Wi-Fi, time synchronized. Great, I'm gonna press the button. And the LED is on. The LED is on, pressing the button. The LED is off now, and the LED is on again. Okay, so yeah, it was off for the time of sending the request. This is how it's supposed to work. So this is it for today. Thanks for watching. As you can see, this video today was way longer than the usual one. So let me know in the comments if you liked it. So I will do more refactoring sessions, or I won't if you didn't like it. Tomorrow, I'm going to be playing around with the temperature, so if you don't want to miss that video, subscribe to my channel. If you have suggestion, question or feedback, leave the comment. Cheers, bye!